Hi, my name is Aditya, and today we will be discussing how to design Instagram. Instagram is a very popular photo sharing application that allows users to upload their own photographs as well as view photographs uploaded by others. So before we jump in, let's first define the use case of Instagram. So we have users here, and we have our system here. So within this, users should be, when using when using the system, they have to log in. So that has to be a use case, right? So after logging in, users will have the ability to upload photographs, browse, and third would be to view their own timeline. Adding the fourth one, following. So users should be able to follow other users that they're interested in, for example, famous celebrities or their own friends. So we have a user logs into the system, then user has four other use cases. They can upload pictures, they can browse the application, they can view their own timeline, as well as follow other users. So let's think about how we can model our users. So a user can be defined as you having some attributes. So if we go over here and we say this is a user. So a user has an ID, a unique ID. A user will have a name, last login, and some other metadata that we can think about later. Let's think about images. So an image can also be defined by an ID. An image will also have an associated user ID. An image will have a date, type, location, and amongst other things as well. But for now, let's focus on these. So each image is associated with one user ID, meaning this is a one-to-N relationship. So thinking about how we can maybe store this, one way would be to have a relational database where we have one table for users, one table for images, and the columns are these different fields. So we have in the users table, we will have ID, name, last login, amongst other columns. For images, we will have an ID, a unique ID, a user ID, which would be a value in this column on this table, and we will have date, type, and location. So we've thought about how we can model a user and an image in our system. One other thing we want to focus on is following. How would users be able to follow other users? So right now, within our model, we haven't yet defined a way for to be able to figure out what users are following what other users. So one way to achieve that would be to have another data store where we have a user ID pointing to a list of user IDs. So this would be a list of IDs. This list of IDs will be will be all the people who are following this user. So for example, if the user ID here is 0, and this is 1, 2, 3, 4, what we're saying here is that user ID 1 follows user 0, user ID 2 follows user 0, and so on and so forth. So this relationship gives us person to followers. Another data store we'll have is user ID to list of user ID to list of user IDs which appear in this user ID's timeline. So this would be a list of IDs which appear in this guy's timeline. So doing this, what happens is that whenever the user goes from here to here, and the user wants to follow another user, what ends up happening is that we go into this data store and we add another new user ID over here. So if this person, let's say this person's user ID was 5, and they want to follow user ID number 0, all we would have to do is go in here and add this person user ID here. So we have 5. So we know that amongst this person's followers, user ID 5 is also among one of them now. So now we've defined how we can model the user, how we can model an image, and how we can also figure out how to follow other users. Let's think about how the system. Let's think about what's the benefit of this approach. One benefit of this approach is that when, for example, we want to populate the feed of user number 5, we already know by this data store here which user IDs should make up the timeline of this user. So instead of querying multiple tables, doing a join, and generating a timeline for user number 5, we already have this pre-computed list, so that makes it more efficient, and it reduces the latency for the users to be able to view their own timeline. One downside of this approach is that while this data store here makes it efficient to look up the IDs, at the same time, if user 0 is someone who's very popular or is a celebrity, this list might be thousands or even hundreds of thousands. So doing that push would be very, very, very expensive. So one kind of approach to address this issue would be to having this pull-based approach for users that are very active, that have very big follower counts, but having a push-based approach for users that aren't as active. So for example, what I'm saying is that if a user has maybe 100,000 followers, we would want to go with a pull-based approach when trying to instead of broadcasting that user's update to everybody's timeline, we would only get that update when other users who are the followers, they they want to see their own timelines, as opposed to someone who has maybe 100 users. We would want to push that out because it's the scale isn't as big. So now we have considered how the following would work. We've considered how the following goes into the timeline. Let's think about this feature, uploading pictures. So uploading pictures is, if we think about it, Instagram is mainly an application where it's more read heavy than write heavy. So what that means is that most users of Instagram would most likely be scrolling through the application to view pictures of their friends or within their own timeline. So it's very read heavy, and these users, far less users would be uploading pictures. So where I'm getting at with this is that if we think about a more architectural diagram of this, where we have, let's say this is a phone, and it interacts with the service. So we have upload here, and we have newsfeed and just browsing. And if we split it up into upload and newsfeed and browsing, what I'm saying is that it would be beneficial to split out the functionality like this, because the traffic that would be going from here to here this way would be magnitudes larger than the traffic from for uploading pictures. So that's one decision we can make. Another thing that we would want in the system is having redundancy or durability in the system. And what I mean by that is, when a user uploads a picture, that user wants that picture to persist in the system. So for example, if one of our servers crashes or our data store crashes, we don't want that information or that picture to be lost. So one way we can address that is having multiple copies of the image store, so that an image isn't, when a user uploads an image, it's not just placed in one image store, it's actually replicated to maybe 2 or 3. So we have this level of redundancy. So let me draw a more complete diagram of the system. So let's see. Go back here. Let's see. So we have our user. So this would be like a client. Okay. Our client will talk to, let's say, a web server through HTTP. So we have a web server, then we have the same kind of flow going on. So we have a web server, it'll go to a login service. So this would be like a login. From login, we split out the functionality. So we have login, and then we have, so let me draw this out. So we have login, upload, we have follow, browse. So like I mentioned, we're splitting out the upload, and upload separately from following and browsing. So following is here. Actually, we can split it out in 3 ways. We'll have following be completely separate. So follow would be on its own, but we can group together browsing and timeline. So this would be browsing. This would be follow and timeline. Because these systems work together, as I mentioned earlier, the following impacts this data structure, and the timeline itself is generated from the second data store we had. So this is following in timeline. So when we upload, this upload service will touch an image store. So we have, let's define an image store. So we have this would be an image store, and we could have multiple image stores for redundancy. In addition, we have these tables as well, which would be metadata. So this could be upload, and this is touching both user metadata. No, not user metadata. Actually, this would be okay. This would only be image metadata, and login would be touching the user. So image metadata. This would be touching user metadata. Okay. So we have a client. The client talks to a web server. The web server then talks to a login service. Login hits the does the logic behind adding a new user, filling out these fields. Then from login, from the user standpoint, we have following in the timeline. We have the browsing. We have uploading, which goes to image store, and image metadata. So that is one design of how we can make Instagram.